A celestial roaming cloud of gas and dust wanders the cosmos, the temperature low enough to harbour the ability for molecular synthesis. This is what is known as a molecular cloud, and it is the starting point for the stars within our universe. These then become what we know as a stellar nursery, which the Orion Nebula is an example that we can locate with the naked eye. When the gas particles within this nebula start to run into each other, this begins to create heat. This results in a warm clump of molecules that we dub a protostar. This creation process can be seen with infrared vision, as the protostar is a lot warmer than the other molecules that make up the interstellar cloud. Several protostars can form, but this is dependent on the size of the cloud itself. The next phase in the star's adolescence is called a T Tauri star. This begins when material stops falling into the protostar. Slowly, stellar winds and radiation blow away the surrounding shell of gas and dust. When the surrounding envelope is cleared, this is when the phase of the T Tauri star begins, which will last for around the next 100 million years. When the core reaches a high enough temperature of nuclear fusion to begin is when it has entered the next stage of its journey. In this process, the protons of hydrogen are converted into atoms of helium. This reaction is exothermic, meaning it is giving off more heat than it requires, and so the core of the main sequence star releases a tremendous amount of energy. A star continues to convert hydrogen atoms into helium over the course of life at its core, but eventually the hydrogen that fuels this will run out, thus causing the next phase of the star's life. Without the reactions occurring within the core, the star contracts inward through gravity, causing it to expand. As it expands, it first becomes a subgiant star, and then as the process continues, it becomes a red giant. Red giants have much cooler surfaces as a main sequence star, and because of this factor, they are red instead of yellow. Helium molecules begin to fuse at the core as the star expands. The energy created by the process prevents the core from collapsing. The core then shrinks and begins fusing carbon as the helium fuel begins to run out. This process will repeat until iron appears in the core. This fusion causes it to absorb the energy, resulting in it collapsing. At this point, most of the star material is blasted into space, but the core will implode into a neutron star, or a singularity known as a black hole. Less massive stars don't implode, but evolve into what is known as a white dwarf, being tiny and hot. This is the future for our sun. These are the stages a star goes through within its life cycle. But if you would like to know more about the formation of black holes, make sure to check out this video.